Hello students and welcome to yet another video on foundation course of business statistics, and in this video we are going to learn yet another type of central tendency, measure of central tendency, and that's mode. So what's mode? The mode is the most frequent value. The mode is that value which occurs most frequently within the data set. So here is the example. So if I have a data set which comprises of 24166889468, so these are the elements in the data set, and if you really see, 6 appears 3 times. So 6 is the most occurring value, and it is mode. Right? So in a data set, we can have one mode, we can have two modes, which is bimodal, or multiple mode. For example, if I have a data set 3, 3, 2, 2, 1, 6, 8, 9. So if this is my data set, then what is my mode? Now you see, in this case, I have 3 occurring twice, 2 occurring twice. So my mode is 3 and 2. So this data set becomes a bimodal data set because it has two modes, right? So this is what it is. Let's move on. Let's consider another example. We just previously saw a simple example of data series. Now let's see a discrete frequency distribution. Discrete frequency distribution, if you remember, we have x and we have frequencies of those values. So for 1 occurs 6 times, 2 occurs 9 times, 3 occurs 16 times, 4 occurs 12 times, and 5 occurs 10 times. So this is my frequency distribution, right? And all that I have to do is I have to find out which is the highest frequency in this. My highest frequency is 16, and 16 is against x value of 3, and that is the reason why mode is value x, which is 3. So this is very easy, simple to find out as far as discrete frequency distribution is concerned. So let's also work upon how to find out mode for group frequency distribution. So for group frequency distribution, there is certain thing which you have to do first. If you have classes given in the distribution, and if that class interval is not exclusive, if that class interval given is inclusive. So if you don't understand what inclusive exclusive classes are, please do go and refer my video on frequency distribution, because that's again very important. But just to recap, inclusive classes are those classes, example is like this: 0 to 4, 5 to 9, 10 to 14, so on and so forth. So there is a gap between lower limit, upper limit of previous class and the lower limit of current class, whereas exclusive class is that class which is like 0 to 5, 5 to 10, 10 to 15. So there is no gap, right? So this is what is exclusive class. So if class intervals are not exclusive, convert it into exclusive. If class width is not equal or it's not uniform, convert it into uniform, convert it into equal. And after that, identify the model class with the highest frequency. So once you get the model class, you have to calculate the mode, and to calculate the mode, you have to apply this formula, which is L plus H into F1 minus F0 divided by 2 F1 minus F0 minus F2. And what is L? L is the lower limit of model class, H is the class interval of model class, and model class is that class which has highest frequency. F1 is the frequency of model class, F0 is the frequency of the class preceding to the model class, and F2 is the frequency of the class succeeding to the model class. Okay, so to understand this, we have an example on the next slide. So let's quickly go through it. So these are my classes, and needless to say, they are of type exclusive type. So I don't have to do anything. 0 to 10, 10 to 20, 20 to 30, so on and so forth. I have 12 numbers between, or 12 elements, data elements between class 0 to in the class having range 0 to 10, 13 elements within class having uh, elements having interval between 10 to 20, so on and so forth. Now all that we have to do is find out what is the maximum frequency. My maximum frequency is 19, so 20 to 30 becomes my model class. So model class is 20 to 30, right? And then I apply my formula. Okay, so here it is. L is 20. L is nothing but lower limit of my model class, which is 20. H is 10. 10 is my interval. F1. So what is my F1? F1 is the frequency of the model class. F2 is the frequency of the model frequency of the class succeeding the model class, and F0 is the frequency of the class preceding the model class, right? So that is 16 and 13 respectively, and I put the values here, and I will get mode as 26.67, right? One of the most important thing that is mentioned in this block below is many a times you get mode which is not unique, right? So although you find maximum number, mode is something which is occurring maximum, but there is a possibility that your mode, you might have a series which is not unimodal, which can be bimodal or multimodal. In that case, there is a empirical formula which has come, okay, and this gives us basically our relationship um, between our central tendency measures that we have seen, right? So mode is equal to 3 median minus 2 mean. Understand what is a empirical formula. Empirical is something which is not mathematically proven, but you would find this pattern. The pattern is noticed on different distributions that is studied by researchers, and that researchers have come up with this empirical formula. So most of the distribution have got this relationship, and as I said, it's an empirical formula, so no mathematical evidence, but it's a kind of pattern that comes out it, and that pattern is mode is equal to 3 median minus 2 mean. Yeah. With this, we actually come to the end of central tendencies. We have seen mean, median, and mode. So in our next video, we will start with measures of dispersions. Till then, thank you so much.